Hello, so today we will be doing exercises on projectile motion by using the formula above as well as maybe the formula below. And if needed, okay, we will also use the equation of the path of projectile. Okay, so let us just go ahead. We will solve these three questions, question 1, question 2, question 3. So let us just see question 1 first. A particle is projected so as to have a range r on a horizontal plane through the point of projection, and the greatest height attained by it is small h. Prove that the maximum horizontal range with this velocity of projection is 2h plus r squared over 8h. Okay, so this is the question. So let us try to solve it. Okay, let me just get rid of this box. Okay, so now let us solve. Okay, so if you are seeing the question, you are saying that, okay, we are throwing a projectile and it has range r. And the greatest height, it is denoted by a small letter which is h. Okay, and also we have something which is called the maximum range. Let us see. You must remember, okay, maybe it should be left as an exercise that the maximum range is achieved when you throw it at an angle of 45 degree. Okay, so over here what we can do, okay, this is the range when the angle is alpha, the velocity of projection is u. If the angle is 45 degree, then you will be having maximum range. Okay, so let us calculate first r max. Okay, the range. Okay, so let me just write it down. R, it is according to the formula above, it is 2u squared sine alpha cos alpha upon g. And we have small h, which is the greatest height. Again, over here in the formula above, it is denoted by capital H, but now we are denoting it with small h according to the question, but it does not change. U squared sine squared alpha upon 2g. For the range is maximum when alpha is equal to pi over 4. Okay, when the angle is 45 degree, then the range is maximum. R max, it will be equal to 2u squared sine pi by 4 cos pi by 4 upon g. So R max, pi by sine pi by 4 1 by root 2, cos pi by 4 1 by root 2. Together they will cancel with this 2, so you will be having u squared upon g. Okay, so this is what we get. So now let us just take a look at the question again. So we have got R max. Now we just want to show that the maximum horizontal range is 2h plus r squared over 8h. Okay, so let us just calculate. Let us just calculate 2h plus r squared by 8h. Okay, now let us just calculate this. So you will be having u squared sine squared alpha upon g. 2h will be 2 times of this plus r squared. R squared will be getting 4 u power 4 sine squared alpha cos squared alpha upon g squared times 1 by 8h. 8h will be, okay, so we will be getting 8 times of this will be 4 u squared sine squared alpha. G will be above, so you'll be having this. Now let us just simplify it. So u squared with u4 will get cancelled. 4 and 4 will get cancelled. Okay, so you'll be having u squared sine squared alpha upon g plus u squared with u4, you will be having u squared sine square will get cancelled, cos squared alpha upon g. What we can do now is we can just we can just take common u square upon g. So overall, you will be having u square by g, which is equal to r max. Okay, so we have done it. Okay, which is equal to r max. So this is the final solution of this problem. Again, it's very easy. Mostly the hints are given in the question itself. Okay, and then you just have to calculate it from the question. Okay, now let us take a look at question number 2. Question number 2 says that particles are projected from the same point in a vertical plane with velocity 2gk. Prove that the locus of the vertices of their paths is the ellipse x squared plus 4y, y minus k. So we are interested in the focus, in the vertex. So we will be needing the formula below. Let us just try to have an understanding of this question. Okay, for question number 2. So we are throwing particles with velocity u equal root 2gk. Velocity of projection u is equal to root 2gk. So over here, what are we doing exactly? We are not mentioning the angle. So it means that you are throwing so many, and also if you take a look at the question, you are seeing the word particles. It is not a particle. So obviously it means that there are more than one particle that you are throwing with this velocity. How exactly you will throw it? You will throw it in so many directions. Okay, so particles are thrown with this velocity, with the same velocity you are throwing it in so many directions. Maybe in this direction, okay, maybe in this direction. Okay, so you can throw it in so many directions, okay, with the same velocity. Now what we have to do in this question is we take a look at the vertex. So the vertex of this first part, it is this one. Again, we can have so many parts. The vertex of this part will be somewhere over here, and the vertex of this part may be somewhere over here. We collect all these vertices. Okay, it says that if you collect all these vertices, it will form an ellipse. That is the meaning of the locus of the vertices is the ellipse. Okay, so if we take any point, or if we collect all these vertices, we will be getting an ellipse. Okay, maybe this picture is not so accurate, but if the picture is really accurate, if we collect all these vertices, okay, for the different parts, for the many parts that we are projecting the particle, if we collect the vertices, we will be having an ellipse. Okay, maybe it will look something like this. Okay, maybe it will look something like an ellipse. Okay, if we collect all their vertices. So let us see. Again, we are having u equal to 2gk. Okay, and so u square will be 2gk. Why am I finding this one? Okay, you will see. Okay, let xy be any point in the locus. If it is any point in the locus, so firstly it will be a vertex. It will be a vertex of one of its parts. Therefore xy is the vertex of one of the parts. Because we are having so many parts, so that's why over here I'm mentioning xy is the vertex of one of the parts. So x, it will be equal to, okay, maybe one of the parts, maybe when the angle is alpha. Okay, so say when the angle of projection is alpha. So this is what we have written. So how much is the value of x? By using the formula below. The vertex is given by r by 2, h. So x will be r by 2. and y will be equal to h. So let us just see how much is x. So x, by using the formula above, r by 2, it will be u squared sine alpha cos alpha upon g, and okay, and u squared, if you remember, how much are we getting? We are getting it to be 2gk. Okay, so 2gk sine alpha cos alpha upon g. G and G will get cancelled, so you'll be getting 2k sine alpha cos alpha. Now let us take a look at y. Y equal h. So y will be equal to the greatest height, u squared sine square alpha upon 2g. Again, u squared, it's equal to 2gk sine square alpha upon 2g. So we will be getting k sine square alpha. So sorry, I forgot to remove this. Okay, so this is what we got. Now, if you just take a look at the question, you will be saying that we need to find this value. We need to show that the locus, again, I will show this question. We need to show that the locus is x squared plus 4y, y minus k. Okay, so we need to show that the locus of the parts is this. It's given by this expression. So sorry, it should be equal to 0. Okay, so it's given, it's the ellipse, this one. So we need to show that this one is equal to 0. So now what we will do, since we want to show that this one is equal to 0, we can just calculate x squared plus 4y into y minus k. So x squared, it will give you 4k squared sine squared alpha cos squared alpha. Maybe we can write this one as 4y squared minus 4yk. So over here again we will be getting this. Now it's just simple simplification. 4y squared, you will be getting 4k squared sine power 4 alpha minus 4k sine squared alpha k. So we'll be getting 4k squared. Now what we will do is, okay, 4k squared sine squared alpha cos squared alpha. Now just take common 4k squared sine squared alpha. You will be getting sine squared alpha minus 1. So sine squared alpha minus 1 will give you minus cos squared alpha. Okay, square sine squared alpha minus cos squared alpha. So this one will get cancelled and you will be getting 0. Hence, what can we conclude from all of this? 4y, y minus k, it's equal to 0. So over here we can conclude that this one, it is the required locus and it is an ellipse. Okay, so we can conclude that it is a locus because the right hand side, it no longer depends on the angle alpha. Okay, in the intermediate steps we are having alpha, but ultimately we are seeing that it no longer depends on alpha. That is why we can conclude that this one is indeed the required locus. If anywhere in this equation alpha is still appearing, then you still need to get rid of alpha. Okay, so I hope that is clear. That is how we find the locus, which is the required locus. Okay, so this solves question number 2. Now let us just take a look at question number 3. These exercises are simple compared to the ones that I will do later. But anyways, let us have a look at question number 3. Question number 3 says that, question number 3, okay, maybe question number 3, I will put it over here. if the focus of the trajectory lies as much below the horizontal plane through the point of projection as the vertex is above, prove that the angle of projection is given by sine alpha equal 1 by root 3. Okay, so let's see. Let us solve this question number 3. So over here, what are we having? Again, we are having a projectile. The velocity is fixed, the angle of projection is fixed, but what happens over here is so we are having a projectile, maybe it's looking something like this. This one, it is the vertex. So the vertex V, okay, the coordinates are r by 2, h. It lies above the horizontal. But what is given about the focus? The focus, it lies below the horizontal by the same distance. So this distance is above the same the horizontal. So that much distance below the horizontal, the focus will lie. So if S is the focus, it will lie below the horizontal. That is why we are having it below. Okay, sometimes this focus will be above, sometimes it will be below, but for this question it is exactly below. So let's see. Okay, so now that we are interested in the focus, we first need to find the coordinates of the focus. If you take a look at the formula below, you will see that the coordinates of this focus is u square sine 2 alpha upon 2g minus u square cos square 2 alpha upon 2g. And also because we are measuring the distance from the horizontal, so that is why we will also need this point. This point, it will be r by 2, 0. Okay, maybe we will need it, maybe we won't. Okay, but let's see. Okay, so solution, that V be the vertex, Vs be the vertex, and the focus according to the figure as in the figure above. Okay, so you will also need to draw this one so that you won't have to describe what is happening. Okay, you can just say it like this. This point, let it be P. Okay, according to the question, we have Vp equal Ps. So Vp, it will be the greatest height, h, and Ps, it will be this coordinate. Because the distance of this point from S, it will be this distance, which is the y coordinate. But we should take the positive one because this negative, okay, it won't play a role. So h, it will be u square cos square 2 alpha upon 2g. Okay, so h will be, instead of h, now I will write the formula which is given by the formula above, u square sine square alpha upon g, u square cos square 2 alpha upon 2g over here Ps, it will be cos 2 alpha. Just make corrections over here in the picture as well. It should be u square sine 2 alpha, u square cos 2 alpha. It is not squared. Okay, it is 2. So just make some corrections. So 2g and 2g will get cancelled, u square and u square. So we will be having sine square alpha equal cos 2 alpha. But cos 2 alpha, you can write it down as cos squared alpha minus sine squared alpha. Again, the question, if you see we are interested in sine, so that's why cos we will convert into sine. So we will be having 1 minus 2 sine squared alpha if you simplify. So we'll be having 3 sine squared alpha equal 1. So ultimately we will be having sine alpha equal root 1 by 3, which is the required answer that we want to find. So this solves all the 3 questions. Until next time.